Folks, let me just find my pen. Oh, here it is. Wait a second. It's exactly under my chair and I can't grab it. There we go. Oh, so out of shape. Alright, I'm going to actually be covering an important concept with you guys, and I'm actually going to be holding a lab on Friday. Hopefully what I'll be able to do is be able to get the lab equipment that I need. So on Friday, I'm going to hold a special lab that I'd like for you guys to come in for. Kiko, I understand that you are on Big Island, so you're going to need to watch this lab for the most part. But I'm going to do my best to help you out. Cool? Alright, so now what we need to do at this point is we need to, I need to show you guys how to use trigonometry. Now I know that some of you guys feel like you know how to use trigonometry, and that's great. And so I'm going to cover with you sines and cosines and all of that kind of stuff. This is called vector addition and whatnot. And this is kind of an important thing. Do you guys remember what I told you about the idea of a vector? What is a vector? And chat it to me. We're going to use the chat bar today. We're not going to use the talk button as much. What is a vector? I'll give you a hint. There we go. What is a vector? Did my computer freeze? Alright, there we go. Is the graphical expression of the distance and direction exactly. It is a magnitude of both distance and direction. Basically, if I'm standing here, okay, and I see you, and I say, "Hi, Justin, how do I get to the library?" Well, what you would say is, okay, you would say, well, you walk a half a mile. And I'll be like, great, I'm going to walk a half mile and I'll get to the library. But the answer is no, you don't. You can't say that. Because if I say that the library is here, which technically is a half a mile away from me. But you say, hey, Justin, how do I get to the library? And you say, walk a half mile. And I say, all right, fine. I walk half a mile. And I'd be like, Justin, dude, I'm not in the library. I'm at the mall or something. I don't know. Or I walk a half a mile. Go. See, in science, we need more information. We cannot just say, walk half a mile. You have to give me, walk a half a mile at this many degrees below east, or something like that. Or walk a half a mile southeast, or southwest. Sorry, this would be west. So that way you're giving me both a distance, the how far I have to go, but not only a distance, but you also have to tell me the direction in which I need to go. Now, let's do this. Here's north, here's east. Let's say you want to go to the mall. And I'm asking Kiko, I say, Kiko, how do I get to the mall? And you say, okay, we'll walk half a mile. 0.5 miles. Does that make sense? But you need to, again, give me a better description. So it would be half a mile. What would the direction be? The direction would be walk half a mile northeast. Very good, exactly. Okay? And I would get straight to the mall. Now, if it didn't matter how much I walked, but what I would rather know is, and you can actually tell me exactly how much north of east. You can say, walk 30 degrees north of east. Cool? Now, if it didn't matter exactly how far I walked, but or even say like I was driving a car, and this, my friends, is actually a park over here. There's a park over there. Well, technically, what you could tell me is you say if I'm starting over here and I want to get to the mall, I could drive half a mile, 30 degrees north of east. True? But I would get arrested because I can't just drive through the mall. Or let's say there's a lake in the middle there. I can't do that. I mean, if I were a bird, maybe I could. I could just fly straight from there to there. But what you would need to tell me instead would be to drive so many miles this way, or maybe a certain amount of distance this way, make a left turn, and drive a certain amount of distance this way. Do you guys agree? I could, if I were a bird, go straight from here to there. But if I were driving in a car, you would have to tell I would have to go this way, and then I would have to go this way. I'd have to go actually, it would probably be less than half a mile this way, and then half a mile, or less than even maybe a quarter of a mile this way. I'm not sure exactly. Do you guys agree? Do you guys see how this works? So now what we're going to be doing in trigonometry, or we're going to be doing in physics class today, is we're going to be learning how to do this. We're going to be learning how to take lines that go from here to here and break them up into lines that go from here to here and lines that go from here to here. We're going to learn how to break them up into their components. That is going to be the point. Because the trick that we're going to be doing is, and I'll tell you now, wait 1 second. Ben, come on in. What's up? What? You gotta talk to me. What's up? Oh, I gave you a banana.
I know, and somebody accidentally stepped on it.
Alright, yeah.
Alrighty, but I'm a natural one left.
You gotta wash that spoon off. Okay. Alright, so we don't actually know how to do physics at angles like this. Or actually, I do know how to do it, but what we do is we know how to do physics that when we're talking about horizontal or vertical. Okay? All of the problems that I've given you so far has been motion in one direction. You've only been going horizontal, or you've only been going vertical. Okay? In this case, we don't live in a one-dimensional world. We actually live in a three-dimensional world. But right now, we're only going to be showing you 2 dimensions. When we take something and move it into 2 dimensions, what we're going to do is we're going to figure out how to break that up into its horizontal parts and its vertical parts. Kiko and Justin, am I making myself clear? You guys aren't talking very much. I'd rather you guys just kind of really chat back with me a lot. Yes? If not, it makes me feel like you guys can't hear me, which actually might even be the case. Can you hear me? Okay, good. I just want to make sure. Make sure you guys chat back with me a lot, okay? So that's what we're going to be learning today, how to break something up into its components. My computer froze. Alright, you know what? I'm not going to rely on whatever they say for the next lesson. Why don't we just do it? Can you guys still see the computer screen? Can you still see my face? because the computer part froze. All right, awesome. So what I'm going to do is I'm going to give us a line, and this is a vector, so it's going to be 0.5 miles, and it's going to be at 30 degrees. So instead of telling me to write, and we usually draw vectors with arrows, and we say, okay, it goes from here to here. Now, what I'm going to do now is, the webcam is just static. All right, well, I guess I'll have to just, I guess I'll just have to go the best I can and then just hopefully rely on the YouTube recording for this thing. Let me see, is the other video process yet? Oh my goodness. All right. Okay, let's do it. So here's what I'm going to do. What you're going to do is you're going to be going half a mile and you're going to be going at 30 degrees. Now, what I'm going to do is I'm going to break this thing up. I'm going to call this D. The distance is equal to half a mile. So I'm going to break this up into its components. Because, like I said, I'm not able to go straight from here to there. I can only go, in the X direction horizontally, and then I can only go vertically, but I can't do both. So I'm going to break this up into the X part and the Y part. And I'm going to call this one D with a little X over here and a D with a little Y here. This stands for the X component of D, and this stands for the Y component of D. If I add dx and dy, it would be equivalent to traveling from here to here. Does that make sense to you? Well, hopefully it makes sense to you. All right. In order to figure out what dx is, I'm going to use this thing that we learned in trigonometry. It's called SOHCAHTOA. Have any of you heard of SOHCAHTOA before? Now, whether or not you can see the board, hopefully you can. All right, you've heard of SOHCAHTOA. What does it stand for? Do you know? What it tells you, actually, you know what? We'll get class finished quickly today. What it tells you is how to figure out, all right, the sine of theta. It's relating, it's a mnemonic device that helps you remember that the sine of theta is equal to the opposite over hypotenuse. Similarly, the cosine of theta is equal to adjacent over hypotenuse. And finally, the tangent of theta is equal to opposite over adjacent. So those are the angles. Sine of theta, the cosine of theta, the tangent of theta. Now, what we can do is the opposite refers to the opposite side of the triangle. So wherever theta is, it's the opposite side. So in this case, if 30 degrees is your angle, then your opposite side is dy. Similarly, if 30 degrees is your angle, then your adjacent side, that's the one that's right next to it, is, well, I guess you can think of, well, the one that's right next to it is dx or d. Yes, but d is given a special name. That's called a hypotenuse. That's because on these right triangles, the hypotenuse is the longest distance that you can talk about. So, we have our adjacent side, we have our opposite side, and we can figure out what these things are equal to by using these relations. So what we can do is we can say, all right, I want to figure out what dx is equal to. So what do I have? What information do I have so far? I have the hypotenuse, and I have the angle, and I'm looking for the adjacent. Which of these trig functions deals with the adjacent, the hypotenuse, and the angle? Which of these three deal with only the adjacent, hypotenuse, and the angle? Are you guys still there? Can you guys hear? I'm sorry, you guys. At this point, I feel like Canvas is tanking. So what I'm going to do is, it might be Canvas, it might be my computer, but this thing is just not working. I can't get my slides to advance. Hopefully this thing is actually recording. I need a new computer, I think. Alright. What I'm going to do is I'm not going to ask you as many questions. I'm just going to start teaching it through. Hopefully the best, at least the what we can get out of this is a good YouTube video to be able to record. Alright. So anyway, the part that deals with the angle and the adjacent side and the hypotenuse would be the cosine of that angle. The cosine of theta is equal to adjacent over hypotenuse. Alright, fine. Cosine of theta is equal to adjacent over hypotenuse. So the adjacent would be the d, the adjacent would be the dx. That's this side right here. And the hypotenuse would be the d. So it would be the dx over d. And if I want to figure out what dx is, I can simply just say, all right, well, let's clear fractions. And so I have dx equals to d cosine theta. We cool? All right. So if I need to plug in numbers, I have dx equals to 1/2 or 0.5 cosine of theta, cosine of 30 degrees. And if I remember correctly, which I'm embarrassed to say, actually, you know what? Let me just pull something up real quick. I need my computer. I'm just going to type this in. Sorry, I'm just looking up something real quick. There we go. That's not what? Yeah, that's what I thought it was. All right. So the angle that we're talking about is 0.5 times the cosine of 30. This is actually the square root of 3 over 2. 0.5 is the same as 1/2. So dx is equal to the square root of 3 over 4. You plug that into your calculator, you figure out what it is. By the way, Justin, I don't know if you can hear me or not. Plug in square root of 3 over 4 and tell me what that answer is. I'm guessing it's somewhere close to about, I don't know, 0.35, maybe? Alright. Let's figure out what dy is equal to. dy is on the opposite side. So when we're dealing with dy on the opposite side, what we're going to want to use is the equation we want to use is the sine of theta. Because the sine of theta is equal to dy over d. It's equal to the opposite, which is the dy, over the adjacent, or the hypotenuse, which is d. If I want to figure out what dy is equal to, I simply just multiply both sides by d. And I end up getting dy is equal to d sine theta. So, dy is equal to 1/2, half a mile, sine of theta, sine of 30. Now sine of 30 degrees is actually equal to 1/2. So this first 1/2 comes from the half a mile. The second 1/2 comes from the sine of 30. So this is actually equal to the square root of 3 over 4. This is equal to 1/4, because 1/2 times 1/2 is 1/4. So what I'm saying here is this. This is what we're doing and why we're doing it. Kiko, if I asked you, I'm standing here, I want to get to the mall, how do I get there? You say, well, it's half a mile away from you, and then you have to walk 30 degrees north of east. Boom. Got it? Or what you could say is you could say, well, what you'll need to do is walk east, just east, for 0.35 miles. There. So I walk east. Then take a left turn and walk just north for a quarter of a mile. So I walk north. And you will end up at the mall. It's not the shortest distance, but if you're not a bird, you won't be able to fly from here to there. Unless you're a bird, you can't fly from there to there. So it's a distance you'll have to travel, but it will get you to the same spot. They're equivalent. This horizontal or this angled line is the same as this horizontal line plus this vertical line. And we use trigonometry to figure out exactly what those numbers are. Does this make sense? I don't know if you can hear me. I hope you can. I know I'm cutting in and out, and it started off as a really good day, and if this class, if I can get this computer to work, I can really feel like I can teach you guys a lot better, but this thing is just frustrating. I don't know what the deal is, why this computer decides I don't want to work today. I apologize for the technical difficulties. I'm doing the best I got with the equipment that I have. I feel like this computer that I have is not good. Alright. So, I'm going to do, you know what? I'm gonna have to cancel. I'm not gonna cancel class, but I'm gonna finish class. I've actually taught you guys for 20 minutes. I'm gonna say, look over this. Hopefully it'll be good. I don't want to put you guys through more of this pain. All right. I'll talk to you guys later. Okay, bye.